In this lecture, we are going to learn about the first-class functions. Understanding first-class functions also helps you to understand what higher-order functions are, what is a closure, and many other important things. So, let's first understand what a first-class function means. A programming language is said to have first-class functions if it treats the functions as first-class citizens. In programming terms, a first-class citizen, also called as the first-class objects, in a programming language is an entity which supports all the operations generally available to other entities. These operations typically include being passed as an argument, returned from a function, assigned to a variable, etc. In Python, all functions are first-class functions. They can be used like any other object. They can be assigned to a variable. They can be stored as items in the data structure. They can be passed as arguments to other functions. And also, a function can be returned by another function as a return value. And when a function takes another function as an argument or returns a function as a return value, those kind of functions are called as higher order functions. Let's move out to the Jupyter notebook and see how functions behave like a first class function. We are in the Jupyter notebook and let's see how Python functions behave like a first class function. To be a first class function, the function can be assigned to a variable. Functions can be an item in the data structure. Functions can be passed as an argument to another function. And functions can be returned by another function. So let's start by assigning a function to a variable. So let's start by assigning the function to a variable. Here we have a simple function multiply with two parameters n1 and n2, and it just returns the product of n1 and n2. Let's define this function. Then we call the function and print the output. So we say print multiply 2, 4. Run it. We get 8. Let's say we pass some other values like 3, 5. And we get the output 15. And let's say you want to share this function with the two different teams. One which is going to multiply only even numbers and other one which is going to multiply only odd numbers. And when you want to give this function to them, you don't want to give the function with a generic name multiply. You want to give them with a specific name. Let's say you want to call it even multiply. So we can say even multiply equals multiply. Same way we can say odd multiply equals multiply. So here we are assigning the function multiply to two different variables, even multiply and odd multiply. The even multiply and odd multiply now behaves like normal variables. This is same as like assigning a equals 10, b equals 20, etc. And also note that we are just passing the name multiply without parenthesis. If you pass it with the parenthesis, then the function will be executed and the result of the function will be assigned to the variable. But here, we are not executing the function, we are just assigning the function directly to the variable. Now let's call this function using this variable name. So we say even multiply of 2, 4. Same way we will say odd multiply of 3, 5. Let's run this. And you see we get the output 8 and 15. So the variables even multiply and odd multiply now behave like a function. When you pass the arguments to them, they execute and return the output the same way as the original function. When we assign the function to a variable, the variable will start pointing to the same memory location as that of the function. So the variable behaves like the function itself. Assigning a function to a variable is a very powerful technique in functional programming. You can have some logic within the function, but when you are assigning it to a variable to call that function, you have the flexibility of calling the function with different names at the runtime. This is something similar to polymorphism. Another advantage is the maintainability of the code. If the function is called at multiple places and at a later point, you decide to change the name of the function, then you have to change the name at all places. But instead, if the function was assigned with a variable, then you have to change the name only at one place, that is, wherever it is assigned. Let's now delete the original function. We will say del multiply. We will run it and it's deleted. Let's try to call this function and print the value. So we get a name error and it says multiply is not defined. This is obvious because we have already deleted this function. But let's try to call these two variables, the even multiply and odd multiply. Let's run it and they give the output. When you assign the function to a variable and even though the original function is deleted, the variables still behave like the function. Because as we discussed, they point to the same memory location where the original function was pointing to. So when we delete the function, only the function definition is deleted and not the memory area. These two variables which are pointing to that memory area still behaves like the original function. Now let's see how we can pass a function as an argument to another function. Let's define two functions, squares and cubes. The squares function will take one parameter and return the square of the given number. In the same way, the cubes will return the cube of the given number. Let's say we want to write some logic where we will pass one number and sometimes we want to get the square of that number and sometimes we want to get the cube of that number. And we don't want to call these two functions based on the condition. We want to call one function which will either do the cube or square based on our requirement. So let's try to do that. We will define a new function, power, which takes two parameters, n and func. N is the number for which we want to find either the square or the cube, and func is the function which we pass as an argument. So in the body of the power function, we apply the function to the value of x and return the result. So if func happens to be the squares, then it returns the square of the given number. Otherwise, if it happens to be the cubes, then it returns the cube of the given number. So let's define this and we will call this power function. We will pass the two parameters, let's say 3, squares. And this time you run it, you will get 9. The squares function is called in this case and that returns the square of 3. Let's call this power function once again and this time we will pass cubes and we will get 27 this time because the cubes function is called and that returns the cube of 3. Passing functions as arguments can be useful for writing more flexible and reusable code. We can pass different functions to achieve different behaviors without having to write separate functions for each behavior. Since power takes another function as a parameter, power is called as a higher order function. Let's see another example on how functions are passed as an argument. So this time we have a list of employees and each item of this list is a dictionary and each dictionary has two items, name and age. Let's define a function named filter by age which takes a dictionary as the parameter and returns those items whose age is equal to 30. Let's add another function named search employees. Here we iterate through the employee list. Then we call the filter by age. So when you iterate through the employee list, it returns each item of the employee which is a dictionary. And this dictionary is passed to the function filter by age. And filter by age will check if the age is equal to 30 and if it is so, then it adds that item to the my list. And finally we return the my list. So let's call this search employees function and print the list which it is going to return. So let's print it and we get the two employee names, Rahul and Sandra. And if you check at the list, we have Rahul and Sandra whose age is 30. And that's what the filter by age is doing. It returns all the employee names whose age is equal to 30. But here we have one limitation. The filter by age is enclosed within the search employees function. Which means whenever we call the search employees function, it will always do the filter by age only. So it is not flexible. We cannot filter by any other means. Suppose you have another function named filter by name or filter by something else. We cannot use it in the search employees or we have to modify the search employees function to make use of them. Instead, if we pass this function as a parameter to the search employees function, then it will be more flexible. Let's modify this function to have this function as a parameter. Let's modify this search employees. We will pass the function as one parameter, the list as another parameter. Inside the function, we will iterate through this employee list. Then we will say if function of e, then mylist.append e of name. So in this case, even if you have a new function, we can pass that as a parameter to this search employees method and filter it based on that function. We will add another function, let's say filter by name, and we will say return emps of name dot starts with s. So this function will return all the names that are starting with s. So we can pass either of these functions, filter by age or filter by name, to the search employees function, and based on which function you pass, the filter will be applied. So let's modify the function call now. So we will say filter by age, comma, employee. And you see, we get the same names, Rahul and Sandra. And then we will call filter by name and run it. And this time we will get Smith and Sandra. These are the two names which starts with the letter S. So search employees is a higher order function here because it takes a function as a parameter and does some logic based on that function. Next we will see how we can use functions in a data structure. We already created two functions, squares and cubes. Let's add them as items to a list. So here we have a math list which has got two items, squares and cubes. So squares and cubes are functions by themselves. Let's see how we can make use of this. We will declare a variable and assign the value 4 to it. Now we will iterate this math list using a for loop. For item in math list, print item of x. So for each item in the math list, it's going to get the item, and since it is a function, we pass the value x to it. So the function will be executed on that value x. So let's run this, and you see the values 16 and 64 printed. First it's going to call the squares function on 4 and returns 16. And then it calls the cubes function on 4 and returns 64. And this way, if you want to execute both functions, squares and cubes together, we can put them in a list and iterate it and call both of them together. So in this lecture, we have seen how to assign a function to a variable, how to pass a function as an argument to another function, and how to make use of function as an item with the data structure. In the next lecture, we will discuss about the nested functions and then see how we can return a function from another function. I hope you have enjoyed this tutorial. I would love to hear from you, your thought on this tutorial. Please leave your comments at the bottom. Please subscribe to this channel and hit the bell icon. Thank you for watching and see you again soon.